Yes, yes, Hardik, go ahead.
I think P well head is equals to P flowing bottom hole pressure.
No, because you see, so this plot is for flow bottom hole pressure, right? And now I'm saying that there is no flow rate. So out of this, the only element that will disappear is delta P friction. Rho GH will still be there. Okay? So that's why the first point is PZ plus P will head. So if somebody asks you, want to ask you about, okay, give me the static bottom hole pressure, and he gives you the wellhead pressure. He tells you, okay, the wellhead pressure now, the well is closed, there's no flow rate. The wellhead pressure gauge is reading, let's say 50 psi. Can you calculate for me the bottom hole pressure? The answer is yes. I add, because I need to know the fluid, of course. I need to know the density. If I have any gas, if I have any water, now assume that this is all average density. And then I know the depth. So that's it. Rho GH, this will give me the hydrostatic pressure. I add to the wellhead pressure, this will give me the static bottom hole pressure. Now, what we found is that when we start flowing, right, you will notice something is interesting. This is what we call the VLP, vertical lift performance, or outflow curve. So it is clear that as the flow rate increases, this part will increase. The friction will increase, right? For more flow rate, more friction. And since this is positive, then that describes the curve going up as the flow rate increases. But we always notice in nodal analysis that in the beginning, there is a small dip that will make the flow bottom hole pressure in the beginning less than the static bottom hole pressure. So let's give you an opportunity. Anybody, any idea why this happens? Considering this equation? So anybody raising their hand? Anybody can try? Why there is this dip here? Okay, as I said. So Hani Ibrahim, تفضل. Hani.
This is used when we kick off the well. So this is an stable condition for the well.
Okay.
For this reason, it has declined and then it started to build up when we have a steady flow from the well.
So you describe what happens, but you didn't describe why. You're right, by the way, but you didn't describe why this goes down.
Yeah, because of the instability for the pressure when we started to kick.